All right, guys, so we're going to be talking about solving right triangles here in part 2 of the 8.3 video. So here is kind of our first type of problem. In this type of problem, we're going to be given two sides. So we know two sides, and we know it's a right triangle, obviously. In this problem, we're missing a few things, and we need to find all of them. So we need to find the length of AC over here. So we need to figure out what AC equals. We need to figure out the measurement of angle A. And we need to find the measurement of angle B. It would be perfectly valid for us to start with any of these things, really. We have enough information to find any one of them. I'm going to go ahead and start by solving for side AC. And in this case, since we have a right triangle with two known sides, kind of the most straightforward process here to solve for this side is just using the Pythagorean theorem. So in this case, we have this has got to be our hypotenuse. 9's got to be the hypotenuse, right? It's across from the right angle. So that's really the only one that's super important, is making sure that this one is C when we do the Pythagorean theorem. These two sides could be A and B. It doesn't really matter which one is which. I'll just go ahead and choose to name it sort of in this way. I guess, based on the lettering, I probably should have chosen something different, but that doesn't matter. So we're going to be solving for this side over here. So we have AC squared plus 6 squared equals 9 squared. Let's go ahead and erase this stuff. We don't really need this anymore. And then solving this equation, we have AC squared equals 36. Not equals, plus 36, pardon me, is equal to 81. There's an equal sign, trust me there. We need to solve this, so we're going to subtract 36 from both sides. We're going to get that AC squared equals 45 with that subtraction, and then we need to take the square root of both sides. So at this point, we kind of have to decide whether we're doing this as a simplified radical, which in that case, this would be 9 times 5, so this is 3. I'm making mistakes all over the place, sorry. 3 square root 5, because square root of 9 is 3, 5 is not reducible. Or if we use a calculator for that, the square root of 45 is around 6.7 approximately. I'm going to go ahead and use the decimal for this problem, but you can do whatever you want in terms of that. You can use the decimal, you can use the exact value. Obviously, the exact value is going to be a little better for finding other answers later on if we wanted to use that side. All right, so let's go ahead, select all that. Let me try that again. Select everything here. Let's move that right down here. Let's try making it a little smaller. Okay, so that's solving for AC. Now we need to solve for one of these two angles. Totally doesn't matter. You could solve for A or B. Both of them are fine. We just need to know two sides. So, yep. I'm going to go ahead and solve for A. So, in order to solve for A, big here, I'm going to name the sides of my triangle. So I have my hypotenuse down here. Across the triangle over here, I have the opposite. And then here would be my adjacent. In this case, since we know all three sides, it's actually, I could use any combination of two, when I'm trying to figure this out, right? So, TOA. Since I know all of them, I could use sine, I could use cosine, I could use tangent, but I would recommend just using the two that you were given. If you have that option available to you, that makes kind of the most sense, the easiest. So I'm going to use these two, which tells me that I need to use sine for this problem. So sine of angle A is going to equal opposite over adjacent. All right, let's go ahead and substitute those values in that we know. So we have sine of angle A equals opposite over adjacent. And then every time we're solving for an angle, we need to be using our inverse trig functions. So we want to take the inverse sine of both of these sides. So we have sine inverse of sine of A is equal to sine inverse of 6 over 9. Obviously, On the left side, our goal here was to be canceling those out and to leave ourselves with A. And then on the right side here, we do need to evaluate this using our calculator. So I'm going to go ahead and use my calculator here to do it. But, you know, Desmos calculator works great. So there we go. That's the answer I'm getting, 41.8 degrees. So that's this one right here. We are missing one more thing. We haven't figured out the measurement of angle B, but we should be able to get that pretty easily. Remember that these two angles always have to be supplementary to each other. So I'm going to go ahead and give myself a little space right here in the middle, maybe. So if we have 90 minus 41.8, that's going to give us this measurement right here, 90 minus 41.8. So I get 48.2. So that's the measurement of angle B. Right here, 48.2. That's it. We solved for all of them. We had several different steps that we had to do. We mixed in the Pythagorean theorem. We did some trigonometry. We used complementary angles. You've got to be able to apply all these different skills in order to do it. Okay, let's move forward. Let's do another one. Feel free to pause the video and try this one. Again, I'm going to do this one pretty similarly. We're starting with kind of the same information. No two sides, we're missing the third, and we're missing two angles. So same exact type of problem as we just did. Again, you could find these in any order you want. I think the best way to go about this is again, just using the Pythagorean theorem to solve for your side. So this is the hypotenuse that I'm missing. So 7 squared plus 10.5 squared equals c squared. Well, you could call that hj or c. I know I used a different naming for that last time. I could also just write this as hj squared as well. In fact, maybe I should do that just to be consistent, whether I use a variable or I use the actual name. Okay, so let's go ahead and add those two things together. So I'm just using my calculator to make this a little easier. 7 squared plus 10.5 squared. So I'm getting 159.25. Equals hj squared. And then I just needed to use the square root. Okay, and then, you know, this is not a very nice number, so finding an exact value here would be pretty messy. I'm just going to go ahead and go with a decimal. I'm going to call this about 12.6 for the approximate value of hj. So this one here is 12.6. All right, from there, we need to find the measurement of our two angles. So pick which one you want. Let's just say we're solving for j, just to do something different. That means that this side over here is my hypotenuse. We have the opposite. We have the adjacent. So for this problem, with opposite and adjacent given to us, we should use tangent. So tangent of j equals opposite over adjacent. Plug that in, plug in the things we know. Tangent of j equals 7 over 10.5. We have to take inverse tangent of both sides of this. So we have tangent inverse of the tangent of j equals tangent inverse of 7 over 10.5. Again, we could have solved for j or h. I just made a decision to do j, just to make a choice. Tangent and tangent inverse cancel out. We have j equals, and then I'm going to again use my calculator here to calculate this. And see right there, I get 33.69. So we're going to round that to 33.7. Again, I'm just choosing to round to one decimal place. You should be told on a given problem what to do. We haven't done h yet, but all we have to do here is 90 minus 33.7. So those angles are going to be complementary to each other, and we figure out that it's 56.3. So 56.3, 33.7. Those are going to be our angle measurements there, and we found everything. We know all the angles, we know all the sides. We've went ahead and we solved this triangle. All right. And one more example here. So here, this one, we're starting with, again, a little bit different information. The last two, we started with two sides, and we didn't know any of the angles. And in this case, we're starting with one side and one of the angles. So here we have a 59-degree angle. I think the quickest thing to figure out would be our other angle. So 90 minus 59 is going to give us 31. So angle A down here is a 31-degree angle. It's a pretty easy one to find out right off the bat. And then we have two sides. To find one of them, we're going to have to use trigonometry because we need to. We only know one side, so we need to use trig. I'm going to go ahead and continue using my 59-degree angle for this problem. So let's label the sides according to that. Hypotenuse, opposite, right across from the angle, adjacent over here. And then I guess I have a choice. I could either solve for the hypotenuse or the opposite first. Doesn't really matter. I'm going to call this side y just to have another variable to reference. But let's say we're going to solve for the hypotenuse. I need to also use the adjacent so that I actually, have one of the lengths here. So adjacent and hypotenuse, they tell us to use cosine, CAH. Right, so it's going to be cosine of our angle equals adjacent over hypotenuse. So that is cosine of 59 degrees equals 12 over x. And there we go. Now we solve this equation. This is the harder one where the x is on the bottom. So we have to get that x out of the denominator, multiplied on both sides. So we end up with x times the cosine of 59 is equal to 12. And then we have to divide both sides by cosine of 59. Remember, we keep it in this exact form. That way we don't have to write out a decimal or round it at all until the very end here. Now we have x is equal to, and we can perform this calculation right here. So we can just take our calculator and figure out what this is. 12 divided by cosine 59. And rounding this to one decimal place, I get this is around 23.3. So that is this side over here. There we go. We are still missing one of the sides, so got a bit of a choice here at last. We could continue to use trigonometry. Right, we can still use trig here. That would be totally fine. We could find the opposite side using trigonometry. We now know two sides of our right triangle, so we could use the Pythagorean theorem. Doesn't really matter. I'm going to continue to use trigonometry just to practice that skill. So in this case, we're now no longer using adjacent hypotenuse. Now we want to solve for the opposite. And I'm going to go ahead and use the given side, the adjacent, opposite adjacent. So that tells me to use tangent. So tangent of our angle is equal to opposite over adjacent. So y over 12. There we go. This one is the slightly easier version where our unknown is in the numerator. All we have to do is multiply both sides by 12. And now we are basically done. Figure out what this is in our calculator. I get that. That's 19.97. Let me just show that real quick. Rounding that to one place, it's actually 20.0. So we'll just call this side 20. And there we go. We've actually figured out all of the sides and all of the angles. We know 1, 2, 3, 1, 2, 3, and we're all done. I'm going to go ahead and stop right there. There is another one here on the next slide. Feel free to try this problem, see if it makes sense to you, kind of the general process. Pretty similar to the last one. And yeah, pause it now if you want to try this. and make sure you do the homework. See you guys later.